All right, more rectangle word problems. So picking up from where we left off yesterday, a rectangle's length is 10 more than twice its width. If its area is 28, how long is it? So let's draw a rectangle. You know, one side is going to be twice the other side plus 10. So I'm just turning this sentence 10 more than is the plus 10. Twice its width, right, is the 2w. But instead of writing 10 plus 2w, it's usually going to be easier if you write the 2w first. Just because when we start distributing, yeah, you're going to want it in that quadratic form, which is with the w's first. So the other side is just w, it's unknown, and the area is 28. So we know that this side times this side has to equal the area. So w times 2w plus 10 must equal 28. Now we can distribute. We've got 2w squared plus 10w equals 28. And at some point here, we want to recognize something. It doesn't necessarily have to be this step. Yeah, but it certainly could be this step. We can divide everything in this equation by 2. And so we want to do that. Divide everything by 2. So what's left here is just a 1. Here we've got a 5. And here we've got a 14. So we're going to end up with w squared plus 5w equals 14. And that's going to save us a lot of trouble. So w squared plus 5w minus 14 must equal 0 by subtracting 14 from both sides. And then we can factor that. What are factors of negative 14 that add to 5? 7 and negative. Yeah. So we've got w plus 7, w minus 2. And which one of those makes sense? So either w here would equal negative 7 or positive 2. Only one of those makes sense for a rectangle's width, though. Which one is it? 2. Yeah, the positive one. 2. Now let's go back. What are they actually asking us in this question? How long is it? So how long is a rectangle? Is it 2 units? There's no, I didn't put any units, so, just say units or whatever.
2 times 2 plus 10.
Yeah, 2 is the width, so the length has to be 2 times 2, because that's what our width was, plus 10. So just plugging into this expression that we created here. 2 times 2 is 4, plus 10. And so we would say it is 14 units. If there's no unit, I would just put the word units in there. Like it doesn't really make sense to say it is 14 long. So you want to just say it's 14 units long. Yeah?
On the homework thing, do you have to write it out, or could you just put like the width equals this and the length equals this? Or did you have to write out the length is this?
You should write it out. Because if you have a word problem, you want to give your answer in words. This is kind of our general rule. Any questions about this type of problem? So from yesterday, we're just really adding this step of turning this sentence into a mathematical expression. Right? 10 more than twice the width. And then at the end, plugging our answer back in to find that length. Okay. Let's do. This is sort of a funny problem, but I think it's kind of cool. A rectangle's length is 7 less than twice its width. Its area. Let's say meters cubed, meters squared. 7 meters. And then the question here is it a square? Is it a square? So, there may be a shorter way to do this, but let's just start out by solving it as we know how. The length, so here's the width. The length is 7 less than, so we put the minus 7 off to the right, twice the width. So again, we're switching that English sentence around to put it into math. 7 less than goes at the end, W goes at the beginning. The area is 49. Okay? W times 2W minus 7, the width times the length should equal 49. Distributing this, 2W squared minus 7W, and I'm just going to go ahead and do this right now, minus 49 equals 0. Okay, now we have to factor this. And it looks hard because 2 times 49 is a really big number. But if you think about it in terms of the factors, this only has one factor, 2. And this only has 2 factors, but they're actually the same thing, 7 and 7. So there's only one other arrangement of those 3 numbers. The factors either have to be 2 and 49, right? We know like 1 and 98 are way too far apart. So 2 and 49 still too far apart. The only other arrangement is to take the 7 over here with the 2, and we have 14 and 7. So negative 14 and positive 7 as our factors that are going to work for us. So this is one time when breaking these numbers up into their factors, I think is going to help you see the Gary's terrific trick thing faster. So we know negative 14 and positive 7 have to be what? Are those our factors? Are those like our final factored form? No, that's just how we rewrite this, right? We're using Gary's terrific trick, breaking this up. So we're just going to rewrite it as 2W squared minus 14W plus 7W minus 49. So using Gary's terrific trick, we've rewritten this because we know that the negative 14 and the positive 7 equal that negative 7. It's really important that you don't get carried away and all of a sudden go, oh, W minus 14, W plus 7, because that's not going to work. W times W is not going to equal 2W squared. So again, check your work. Whenever you get those factors, check your work. Gary's terrific trick. Factor this by grouping. We've got 2W squared minus 14W. What can we pull out of that? A 2 and a W. Leaving W minus 7. Then we've got 7W minus 49. What can we pull out of that one? 7, leaving w minus 7 again. So our factors are w minus 7 and 2w plus 7. Now we can check that. Does this thing actually multiply out to equal this? Well, the w and the 2w are going to make 2w squared. The 7 and the negative 7 are going to make negative 49. And then we're going to have minus 14w and plus 7w. That sounds like minus 7w. Okay, so even just in your head, take the time to do that, to check, to make sure that it FOILs out correctly. And on a test or a quiz, I would probably actually write it out. I think it's worth that extra 10 seconds that it might take you to FOIL it. Okay, only one of these is going to make sense. W must equal 7. Okay, so we know that W is 7. Now what were they asking us in this question? Is this a square? How do we know if it's a square? Yeah, the sides would have to be the same. So are the sides the same? We know this side is 7. Let's find out what this side is. 2 times 7 minus 7. That's going to be 14 minus 7, which is going to be 7. So is it a square?
Yes.
Yes. Yes, it is a square. All right. This one, let's do one more problem. This one's going to be a little bit more complicated. I love word problems. All right. So, if each side of a square is increased by 6 inches, the area gets 16 times bigger. Find the side length of the original square. So, yeah. So we've got a square. We know both sides are x. And then we've got another square. What do we know about the sides of this square? Yeah, so increased by 6 would be 6x? Is that right? X plus 6, okay. What is the area of this square? Okay, this one is 16 times bigger. But what is the area here? Is it just A? Because A stands for area? X squared. Okay. And then what's the area of this one?
16 plus. Or no, x squared times 16.
Yeah, so x squared times 16 would be 16x squared. Alright, so we've got this one, we've got this one. Okay. Now we know that this squared has to equal this. We also know that this squared has to equal this, but that doesn't really help us, because we already know that x squared equals x squared. So this square is the one that we're going to have to use. So we know that x plus 6 squared has to equal 16x squared. And this is going to be a problem that we can solve once we FOIL this. So perfect squares always have the formula a squared plus 2ab, so 12a, plus b squared. Okay. Now we need to get one side equal to 0. I'm going to move everything over there because I want to keep my x squared term positive. So I'm going to have 0 equals 15x squared. Why did I switch to a's? Why I put an a there? Minus 12a. Oh, I was thinking of minus 12x minus 36. And then I'm just going to rewrite that up here. So 0 equals 15x squared minus 12x minus 36. Now, unfortunately, this is a 15. Because otherwise, we could divide like a 4 or a 2 into everything.
It's 3.
Oh, we can divide a 3 into everything. Good. So let's divide everything by 3. 0 equals 5x squared minus 4x minus 12. Okay. So now I need factors of 60, or negative 60, to add up to negative 4. So negative 60. What factors of that are going to add up to 4? 60 and 1, no. 30 and 2, no. 3 and 20. 4.
10 and 6. Yeah.
10 and 6. Which one should be negative?
10.
Yeah, so negative 10 and positive 6. We're going to rewrite this using Gary's terrific trick. 5x squared, write the negative one first, minus 10x, plus 6x minus 12. Factor by grouping. 5x times x minus 2 plus 6 times x minus 2 is just the factors of x minus 2 and 5x plus. And actually, if I was doing a problem like this, I would just stop right there. Like, it doesn't even matter. This is going to be a negative number. So I don't care about this factor. I don't even really have to finish that thought. I know that x minus 2 is going to give me the positive result that I want. So x would equal 2, making the original side 2, because that's what x was. So the length is 2 inches. And then we're done.
I have a question.
Yeah.
How did you get that 12?
How did I get what?
That 12.
Wait, what?
Yeah. Like x squared plus 12x plus 12.
Yeah, that was like tripping.
What? Plus 12.
Oh,
Yeah, where's
so I just did this. X plus 6 times x plus 6. So you've got x squared plus 6x plus 6x plus 36. But I had a math teacher in high school that made me memorize that a plus b squared equals a squared plus 2ab plus b squared. So I knew that it was going to be a squared. And this is not really that hard to memorize once you see it enough. It's just doubling this number in the middle here. That's all I really had to, that's all you really have to remember. So I just doubled 6 to get the 12. It's kind of like a shortcut that I learned. Foil, there's nothing wrong with foil though. You get the same thing that way. It's kind of like, we went over the difference of two squares, which I think is a more useful pattern than this one. This pattern is just, it's a little bit too complicated to really be useful. But when you have a perfect square, the middle term is just 2 times the other 2 terms. So 2 times x times 6, which is 12x. And the end terms are just each term squared.
What am I doing the geometry?
Like that. So the other thing I want to say though, I just want to remind you guys of this type of problem, because these ones come up a lot. We're not going to solve this. I don't even know if this will be solvable. But let's say you had a problem like this, right? The size of a carpet is 12 by 15 feet. And then let's say, how big, or sorry, how much room will be left around the carpet if it is placed in a room that is, I don't know, let's just say 1,000 square feet. 1,000. What is 1,000 square feet? That's an area. Right? Whenever you see square units, you know that it's talking about area. So let's just set this one up. It's not going to come out nicely. But the idea here, again, is you have this carpet, which is 12 by 15, and it's in a room. And the key step in any problem like this is recognizing that x is going to be this width, and that this width. So I should have said it is placed like exactly in the center. Of a room that is 1,000 square feet. So the key thing is recognizing that x is the same all the way around. So in this problem, we know the area of this whole room, and we can figure out the width and the length by adding x and x to the length and width of the carpet. So the setup for this problem would be 12 plus 2x, or 2x plus 12, times 15 plus 2x equals 1,000. Right. This length, this whole length here, is 15 plus 2x, because it's x, 15, and then another x. And this whole length here is 12 plus 2x, because it's x, 12, and then another x. And then this length times this width, or whatever, equals the area of that room. So I just wanted you guys to see another problem like this, because these come up, and I think it's really easy to kind of get confused with these problems. But remember, this, like, exterior border length, whatever you want to call it, is usually going to be x in these types of problems. Okay? All right, let's put stuff